In the last class, we saw the types of matrices, and if you remember in the earlier class also, when we are constructing a matrix, one of the important operation we made in the matrix is the matrix multiplication. Okay, that's a very important operation. Okay, because matrix multiplication is the one how you are defining the matrix multiplication based on which you can solve many problems. Okay, so it is not just multiplication, even you can add up, you can add matrices, okay, and many operations you can do. Okay, so all these operations collectively they called as your algebra of matrices. Okay, we will start with that matrix multiplication because already we have seen it already. How is that? Okay, so first operation what we are going to call is a matrix multiplication. Okay, so if you remember, how do we multiply a matrix? If you remember, we draw, we took a small example, correct? A11, A12, A21, A22 square matrix I am taking. And here also B11, B12, C11, sorry, what am I doing? C2, B21, B22. You remember how did we multiply? For the row with the column. When you multiply this each element of the row of first matrix with the each element of the first column of the matrix, and when you sum them up all, that gives the first element. So that will be what? Tell me. A11, B11 plus A12, B12. So this gives, yeah, B21, sorry. A12 and B21. Correct. Am I right? A11, B11, A12 and B21. Perfect, good. So then this row and the second column makes its first row, second column. Correct? So that will be what? A11 into B12 plus A12, B22. And similarly here when I go for second row, first column will give you the first element. Second row and the second column will give you the second element. So what it will be? A21 into B11 plus A22 into B21. This is important. Never reverse it. Okay, so it's a very common practice. People sometimes they use the row here and the column here. Always remember, first one is row, second one is column. Okay, and so this will be, second one is A21, B21, B12. Am I right? Tell.
A22, B22.
B22. Correct? Yeah. So this is the way the matrix can be multiplied. For example, we have taken a square matrix, correct? I can simply do it for a 3 cross 3 matrix also. So let us, whether they give you the symbolic form? You can write actually this whole matrix multiplication in a symbolic form. Yeah, correct. They are given. So that's very nice. We can write it. Okay, so this, this matrix is a new matrix, correct? So I can call this matrix as C11, C12, C21 and C22. Okay. So, and or I will come to it later because there's one more quantity we need to know. What do we mean by that? Okay, so this is one way. Suppose I am giving another matrix. Say for example, you can simply do for 3 cross 3 matrix also. This is 2 cross 2, 2 by 2, whatever you. 2 by 2. You understand what the meaning of 2 by 2, right? 2 rows and 2 columns. If I give you 2 by 3, that means A11, A12, A13, A21, A22, A23. This is 2 by 3 matrix, right? It's 2 row and 3 columns. So if I am multiplying this with another matrix, I'll put 3 by 2. That is B11, B12, B21, B222, B31, B32. You can still multiply them both. Correct? So what will you get? Tell me.
A11, B11.
Correct. A11, B11, because this row and this column. Okay, and easily you can see number of elements as equal. 3 elements, here also 3 elements. So you can multiply this on this, plus this and this, plus this and this. Correct? So plus, tell me.
A12,
A12,
B21,
B21 plus
A13,
A13,
B31.
31. Okay, and I guess I may run out of space. No, we'll be able to do it. So next one, this row and this column. Correct? So what it will be? Tell.
A11,
A11,
B12,
B12 plus
A12,
A12, B22. Correct? A12, B22 plus
A13,
hmm,
A13, B32.
A13, B32. Correct? And tell me, now what about this? This will be this second row and the first column. Correct? So what it will be? Tell me.
A31,
No.
A21,
A21,
B11,
A21, B11 plus
A22,
A22,
B21,
B21 plus
A23,
A23,
B31,
B31. Okay, this is over. Okay, second row, first column. Second row, first column. We got the answer. Now second is second row, second column. Correct? So that will be what? Tell me. A, second row and the second column. A21, B12. B12
A22,
plus A22,
B3, B22,
B22 plus
A23, B32,
yeah, A23,
B32.
B32. Correct? Yeah. Now can you see an interesting thing? What is the order of this matrix? 2 by 3. Correct? What is the order of this matrix?
3 by 2.
Huh?
3 by 2.
3 by 2. What is the order of this matrix?
2 by 2.
2 by 2. Can you understand this one? Can you find any pattern?
No.
Hmm? You're able to find out. It's 2 by 2. These two will be equal, right? So let us take one more example. By that you will become more clearer. What is that I am going to say? Okay, so this is yeah. So let us take one more example. I want to make a more complex example. Okay, though the board is small, I will not be able to do it. So let us take, for example, how can I do a complex way? Yeah, so let us, okay, fine. So let us make another matrix like A11, A12, A13, and I am going to make a, this is 3, I'll make it one more, A14. Okay, so what it will be? Tell me. So then I am going to make 4. Okay, so this will be and what tell me? A21, A22, A23, A24, A31, A32, A33, A34. Okay, so what is the order of the matrix? This is 3 cross 4. Am I right? So let me multiply with the 4 cross 2 matrix. Okay, so what am I going to do? 4 cross 2 matrix, right? Let me remove this one. 4 cross means 4 rows and 2 columns. So this will be B11, B12, B21, B22, B31, B32, B41, B42. Let us try to understand what this multiplication will be. I may not able to write everything because of the space. So this is what's the order? This is 4 cross 2. Okay. And so now let us try to okay, let me remove this one. Then only we will be able to get a space. But you remember, okay, I am removing, but you have to remember how the way we multiply. Okay, there's an important property we are going to, important thing we are going to draw from this matrix multiplication. So this will be, tell me what it will be. First one is, we can do A11 because there are first row, first column, there are 1, 2, 3, 4, 1, 2, 3, 4, we can actually do it, correct? So what it will be, tell me? A11, B11 plus A12, I think I will not be able to write it here, the space will be short. Okay, let me write it down. Equal to, tell me, A11, B11 plus A12, B21 plus A13, B31, A14, B41. Okay, and this into this. Possible, right? First row, second column will give me the column. Okay, so what it will be, tell me?
A21.
First row, na? First row and second column, na? What are you doing?
A1.
Because see, first row, first column gave me this element, first element. Now I want to, I have to still one more row, right? One more column, right? I can always go for one more column also. So let me do that. This is first row, second column. You have to finish everything. So what will be? A1, B12 plus B22 plus A13, B32 plus A14 into B42. Can I go any further? Is there any third column? No, we can't do it, right? So you have to stop it because there are only two columns. I can go up to two columns only. Then all I can do is go for the second row, first column, second row, second column. Correct? Now again I can go anything further with the second row. Similarly, I can go for third row, first column, third row, second column. So we'll have one element here, one element here, one element here, and one element here. Correct? So let us write it down so that make it simpler, easier. So second row, first column. Tell me what it is. A21, B11. Remember, you have to multiply the element and keep adding. First element, second element, third element, and fourth element you have to adding. Okay, this is simpler. Okay, these definitions all are very simpler. So only thing is you should remember. What is that? A21, B11 plus A21 plus B31 plus
A24, B41.
I will show you by writing this multiplication, you can solve many problems very easily. Once I define this multiplication, that we will see in the next. As we go, I will show you. And the next one is second row, second column. That gives me the second row and second column. This is the value. Tell me what it is.
A21, B12.
I am not seeing there. If anything is wrong, it is you. It's not me. Okay. A22,
A22, B22.
B22,
Plus A23, B32.
23, B32,
Plus A24, B42.
okay. And then again we have one more row. Third row, first column. Tell me.
A31, B11.
Okay.
A32, B21.
B21 plus
A33, B31.
B31 plus
A34, B41.
okay. And actually we need to note those values. That will be easier for us to, when we write down this. We can write this in the form of what you call a summation. Okay, because you can see a pattern, correct? This pattern can be written as a summation symbol and we can write that, we will see. Okay, so and tell me the last one.
A31 B12
A31 B12 plus
A32 B22
3B
22 B32 B33
B32 na?
B33
A33 B32. Tell me proper. Then A
A34 B42
B42. That's it, right? Now can you tell me what is the order of this matrix? 1, 2, 3. 3 rows. How many columns?
2 columns.
So this becomes 3 into 2. Can you see a pattern?
The first
Yes. So the first row and the second column will be the always when that means if I give you a matrix and not only that, okay, let us I will come. If I give you a matrix M cross N, okay, M by N, if I multiply with another matrix of say P, okay, I will come there, okay. Another matrix with N cross say P, let us. So the resultant matrix will be M cross P. Okay, and there's a one interesting thing. Here, if you see, this is 3 cross 4 and 4 cross 2. If I just swap this matrix, can you multiply? Let us see. You want to see? So let us see. What I am saying is I am going to swap this matrix. So if this is a matrix A and this is matrix B, correct? I am going to put B into A. I am going to multiply B by A. So what happens? The matrix will be B11, B12, B21, B22, B31, B32, 41 and B42 multiplied by, here this will be
A11
A11, A12, A13, A14, A21, A22, A23, A44, sorry, 24. Am I right? See, I am writing wrong, you correct me. A31, A32, A33, A34 and A41, A42, A43 and A44. Can you multiply these two? Is it possible? How? How do you multiply? First row and the first column, correct? How many elements are there in the first row?
2 elements.
See, I will show you. How many elements you have?
You can
2 elements, correct? And how many elements in the first column? 4 elements. Is there any way can you write in this form? You can't. Okay. So remember, for matrix multiplication, so we can only do when the column, the number of column of the first matrix is equal to the number of row of the second matrix. Then only you can multiply it. You got it? Therefore, see first, see 3 cross 4. That is the number of column in the first matrix. When it is equal to 4 cross 2, number of rows of the second matrix, then only you can multiply. Otherwise, you can't multiply. So this is what they call as a conform. Then this is okay. So when you have matrix of this form, that means the column of this matrix A is equal to the row of the matrix P. Then you call these two matrices conformable. Okay, this is non-conformable. Okay, so you can't multiply this matrix. So one of the important property for a matrix multiplication is, what is that? Let us write it down. Okay, that's important. So I need this one. I will write it here. Okay, so one of the important property is, what is that? The number of column of first matrix should be equal to number of rows of the second matrix. So this is the one property, interesting property we have seen. If it is not satisfied, then you can't multiply those two matrices at all. Okay, that means, what I mean is, this number of rows, number of columns of this A matrix should be equal to number of rows of the second matrix. Then only you can get the multiply the matrices. And the second property is also interesting. What is that? When this is, then you call conformable. Okay, so this we call it as a conformable. Okay. Then what am I going to say is, when you multiply a conformable matrix, the resultant matrix will have the rows equal to the first matrix and the column equal to the second matrix. Okay, when conformable are multiplied, the resultant matrix will have row equal to first matrix. Okay? Am I right? Yeah, row equal to first matrix and column equal to second matrix. Okay? So this is a second interesting property of the matrix. Now, so let us now try to see. See, this is a very nice pattern you can see. Is there any way you can write this pattern as a summation? You remember, now we can write it as a summation of numbers. So if you see here, 1, 1, 1, 1, 2, 1, 2, 2, 1, 1, 3, 3, 1, 1, 4, 4, 1. Correct? So here, 1, 1, 1, 2. 1, 2, 2, 2, 1, 3, 3, 2. So you see some pattern, correct? So is there any way you can write this? It's a summation.
Because these ones, the second element of the A
Yeah.
and the first element of B is the same.
Correct. Summation of, is there something like A1? See, all the first elements are 1, 1, 1, 1, 1, correct? A1, and second element is going to change. 1, 2, 3, 4, correct? I'll call it as I equal to 1 to 4, correct? And then B you see. B again, first, the second index is same, 1, 1, 1, 1, 1, 1. The first index is 1, 2, 3, 4. Same number. So this will be B of I1. Correct? It's nice way to writing, right? Instead of long one, I can write it like this. So tell me for this, what it will be? Here also. See, this is 1. All are 1. Correct? For first element is 1. So I can write, I will remove this one, A and B. So we'll get some space. So this is going to be summation of, again, I equal to, because this is 1, 2, 3, 4. It's also going to 4, I equal to 1 to 4. I can write, simply write it. So then A will be, the first digit, first index is always 1, correct? So 1. And the second one is I. And then you see for the B. B, second one is 2. First one is I. Can you see a pattern? So this is first row, first column. Second row, second column. You got it? First row, second column. And now let us see here. So let us write this one. So here also, if you see, now this 2 is common. So of course A will be 2 will come out, and then is 1, 2, 3, 4. So I equal to 1 to 4, A of 2I. Correct? Into B will be what? 1 is common. 1, 1, 1, 1. Correct? So this is B1 is there. The previous number is 1, 2, 3, 4. This is I1. Clear? Now you can simply now you got the pattern. Am I right? So I can I equal to 1, 4. Yeah, A will be
A2I
2.
B,
Correct. Tell me A2I, B,
I2.
I2.
It's A2I.
Oh, sorry, A2I. And what this will be, tell me? With I equal to 1 and 4. Here itself we can say.
A3I
Correct. A3I, B,
I1.
I1. Correct? Because that's the way you can see it out. So you can see a nice pattern. Therefore, this will be summation of, tell me, I equal to 1 to 4. This will be
A3I B2I.
A3I, B, I2. What? Therefore, so this is interesting. So therefore, I will remove it. So then I can, instead of writing this a long one, I can write in terms of summation. Correct? So then this matrix A cross B will be, I can simply write it as, tell me what is the first element? Summation of I equal to 1 to 4 A of, tell me, 1I B I1 summation of I equal to 1 to 4 A of 1I B I2. Then the next one, correct? Summation of I equal to 1 to 4 A of 2I B I1 summation of I equal to 1 to 4 A of B I2. Then the last one, correct? So that is summation of I equal to 1 to 4 A3I B I1 summation of I equal to 1 to 4 A3I B I2. Alright. So this is a very easy way of writing the matrix. There is no need to write this long. So this is this is what we call this is how the matrix multiplication is defined. Okay, so there is still one more thing I wanted to write. Okay, so when the matrices are so what we saw is we wrote it right. What we saw is A into B is not equal to B into A. We didn't prove this. This is obvious when the matrix is non-conformable. Correct? Suppose if I give a square matrix. Square matrix, is it allowed? So for example, let us take a simple square matrix. I am going to take A11, A12, 2 cross 2 matrix, A21, A22. Simple, correct? So B11, B12, B21 and B22. This is conformable because this can be multiplied. Tell me what will be the answer. And the reverse is also conformable. Correct? BA is also, this is A into B. Tell me what's the answer for this?
A11,
So, can we put it in the summation form? So, what will be summation? I equal to 1 to 2, A of 1I B I1. Correct? And this will be summation of I equal to 1 to 2, A of 1I B I2. And this will be summation of I equal to 1 to 2, A2I B I1, summation of 1 I equal to 1 to 2, A 2I B 2I. Okay? So now let us invert the problem. Okay? What I am going to do? B into A. That is B1. Tell me B11, B12, B21, B22 into A11, A12, A21 and A22. Tell me what it will be.
Summation of
I equal to 1 to 2.
B1I AI1.
B1I A
I1.
I1. Okay, and this will be I equal to 1 to 2.
B1I
B1I A
I2.
I2, and this will be summation of I equal to 1 to 2 B
B1I A no B2I
B2Y A
I1.
I1, and summation of I equal to 1 to 2 B 2I.
I2.
Are they both same?
No, the B and A is okay.
Yeah, they are swapped, na? They are not same. Okay, so therefore A dot B, even in a matrix, in the square matrix, A multiplied by B will not be equal to B multiplied by A. Unlike your normal numbers, 2 into 3 is equal to 3 into 2. Okay, so AB is not that's what you call as your commutative property. Am I right? And then the associative property also you have. So matrices are not commutative. Okay, so means AB is not equal to B into A. Perfect. So this is okay. So now then there's another one important property when you define this matrix algebra, equality of matrices. Actually we came here. These two matrices are not equal. Two matrices are equal only when element by element are equal. Then only call the matrices are equal. So what is that? So equality of matrices. So well, when do you call the equality of matrices? Yeah, let me write it. Okay, equality of matrices. So two matrices are equal. Okay, so that means a matrix A and B are equal only if A of ij is equal to B of ij. Each element has to be equal. Then only we can write the matrix are equal. Okay. So once and then if I define the equality of matrix and so then okay, so then let me write it this one. Okay, so then I can write this matrix as, I'll call this matrix as C, correct? So I can write it as C of 1, 1, C of 1, 2, C of 2, 1 and C of 2, 2, correct? And then you can see C of 1, 1 is nothing but A of summation of A of I and V. Therefore, what I can write is C of ij will be, tell me.
Will be summation of I equal to 1. Maybe
Here it will not be I, it will be k equal to 1 to 4. Okay, and this will be what? Tell me.
It can't be 4 because we don't know if it's 4.
All are 4, na? Anyway, ij we have kept. So now this will be I, k and B of kj. Is that correct? Now put the value. When my I equal to 1 and j equal to 1, that means this value. The corresponding thing is I equal to 1 and j equal to 1, they will be same, correct? So this value comes. Similarly, when I equal to 2, you can keep substituting it and you can see.
For any other
Which one?
matrix, but for any other matrix,
Ah.
that would be 4, right? Summation. What? It could be 1 to 4. It could be different.
Yeah, the number will be different. Yeah, I wrote it 4. I wrote it for this matrix. In general, see what happened here. If you see, what is of why 4 is coming? Because 3 cross 4 into 4 cross 2. If you have m cross n and n cross p, then this 4 will become simply n. Correct? You are right. Very good. That's right. Correct. So in general, that's the rule. We got it 4 because we are taking 3 cross 4 and 4 cross 2. For any general, this number will come into picture. Okay, because we saw the final matrix will be your m cross p matrix. Cool. So this is what your matrices. Okay, we can do, and the equality of matrices also we wrote. And there anything is there? Okay, I can show you something very interesting with these matrices. Okay, and yeah, the other property is okay. There is the other property is addition of matrix. So we will come there to addition of matrix and the constant multiplication of a matrix. Before that, I will show you how. See, we have seen this all this matrix and all. Correct. So we are seeing as some mathematical jugglery we are doing. When you do a real mathematics problem, how we can form a matrix? Answer, this is very simple. Which one I will remove? Yeah, fine. So let me remove all this. So I will go to a 10th standard problem. Okay, so what you learned 10th standard, many things unknowingly you are actually solving matrix problems, but you are not knowing that you are actually solving matrix problems. Okay, for example, let us take a simple problem. Linear equations in 2 variables. You remember? So what you have, ax plus by plus c equal to 0, or you call a1x, b1x, c1, b1y and c1 equal to 0, a2x plus b2y plus c2 equal to 0. You remember this equation? You have solved it? You solve by using substitution method, lot many methods you solve, right? And cross multiplication method also. So I can write this as a1x plus b1y equal to minus c1. Am I right? a2x plus b2y equal to minus c2. Now you can actually write this equation as a matrix. You want to see how? Correct? Is that right? So this matrix contains 2 equations. a1x plus b1y, that should be equal to, because when I equate, the element by element should be equal. See, if you see, so what is the order of this matrix? This is 2 cross 2, correct? And this is 2 cross 1. So the resultant matrix will be
2 cross 1.
correct. Because you remember, so resultant matrix is going to be 2 cross 1, and that's what this is. So then the element by element has to match. They are equal. You were saying they both are equal. Equality of the matrix says element by element has to be equal. Correct. That means what you are saying is a1x plus b1y equal to c1. That's what minus c1. That's what your equation 1. a2x plus b2y equal to minus c2. That's what your second equation. Okay, so a linear equation can be seen as a matrix problem. All the linear equation what you are solving, they basically were solving a matrix problem. Okay, so this is a way you can get it. So now, yeah, we will see. I have written it, correct? I have not solved it. Now you see how we will solve using matrix. That also you have done. Unknowingly, you are actually solving matrix. Unknowingly, you are using something called as cross multiplication method. Okay, cross multiplication method is nothing but you are actually using matrix. Okay, we will see that. So and there's one more thing I can write. See, this is from here itself I can say what will be the addition of 2 matrices. How can I write it like this? See, for example, see, yeah, if I want to write it in different form. Okay, let me put up numbers for that. Then it will be easier to understand. So I am going to have two equations. So the point is we saw what the multiplication means. And we saw what the equal matrices is. Now I am going to write the addition of matrices. What am I saying? Addition of matrices. Okay. What was the number? 1, 2, 3. Correct? So let us write it in a very simple form, try to understand. I am going to have an equation 5x plus 4y, 5x plus 4y equal to 3, and let us say another 2x minus 2y equal to 5. You can solve this problem? So in a matrix, how will we write this problem? Tell me. 5, 4, 2 and minus 2, and here it will be x, y, and here it will be 3, 5. Okay. Now I am going to write this equation. I want to see what will happen if I am going to add two matrices. I can see it from here itself. If I 5x, if I write it as 2x plus 3x plus 2y equal to 3. Let me write it down like this. Okay. So and then what will I write? So I will write this as correct. Yeah. So then I will combine these two. 2x plus 2y plus 3x plus 2y. Correct? I can write it, na? You got it? So I am going to write. So this I am going to write as 2x plus 2y plus 3x plus 2y equal to 3. Correct? And I am going to take this one also. Let us write this one as x plus x minus y equal to 5. So this again common x minus y plus x minus y equal to 5. Correct? So now, if you see carefully, so this is one equation, right? So this I wrote it like this. So let me write this also in a matrix form. So there I can see this one can form a matrix. I can write like, so let us take, say I'll use a different color, so you will be able to differentiate it. I am going to write this portion and this portion. Okay, so what will be this portion? 2, 2, 1, minus 1. Correct? And here this will be x and y. Am I right? So 2x plus 2y, x minus y. And then I will write plus again here 3, 2, 1 and minus 1. Here also will be xy, and that will be 3, 5. See, this has to be plus because only the number will get added because the plus is there. Correct? So now, if I take commonly outside, x and y I can take commonly outside. So then what we are having is 2, 2, 1 minus 1 plus 3, 2, 1 minus 1 multiplied by x, y equal to 3 and 5. Correct? Am I right? Now these two has to be equal. Is that correct? These two are equal. Because the same equation we wrote it like this. So now what it says? So now you see, so this is equal means 3, 5 is equal, xy is equal. So these two matrices also should be equal. So when you add a matrix, what is happening? 2 plus 3, 5. 2 plus 2, 4. 1 plus 1, 2. Minus 1 plus minus 1, minus 2. So when you add the two matrices, what means you add element by element. If you remember, in the last class I said you can't add two matrices if their orders are different. You got it? Suppose if I have 2 by 2 and other one I am having 3 by 2. Can you add? That won't fall into it at all. Correct? So that's why I told you, if you remember in the earlier class, then we subtract when I defining a null matrix. Why a matrix with 0 elements is important? Because what matters is the order. When I want to add with the 0 with something, I should get the same order of the matrix. Okay? So that's what addition of matrices. So in addition of matrices, you just add each element by element. Okay? So that's the way addition of matrices. And then the other thing also, see, that is very simpler. You can always find it out. See, this, here itself you will find it. So you can what they call a scalar multiplication with a matrix. Scalar means if you multiply a constant factor with a matrix. Okay, so suppose for example, I am multiplying both the equations by 2. So what happens? So this is going to become 10x, 8y equal to 6. So 10x, 8y, 6. This will be 4x, 4y, 10. 4x minus 4 minus 4, 10. So I can equally take the whole 2 commonly outside. You got it? So that's what you call as your scalar multiplication of a matrix. Okay. Do they have any other thing in your book? Let me try to see. Have I missed anything more? Yeah. Yeah, see there, that's it. Simple. They are giving examples. So what happened? If A is a matrix, any matrix, and K is a scalar, K is some number. It can be any number. Then a matrix obtained by multiplying each element of A by the scalar is called as a scalar multiple. Okay, so, and it's not going to really change it also. You can always multiply by the same number. Okay, so that's what your scalar multiplication with a matrix, and that's it. Okay, these are the basic algebra. What we will, algebra we can do with the matrices. Okay.